This is SpaceTime Series 22, Episode 67. Coming up on SpaceTime, India fails in its bid to land on the surface of the Moon, 172 asteroids now considered a risk to Earth, and another claim of microbial fossils discovered in a Martian meteorite. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
India has failed in its attempt to land a spacecraft on the surface of the Moon. Mission managers suddenly lost contact with their Vikram lunar lander just 2 kilometres above the Moon's surface. The lander was attempting a touchdown near the lunar South Pole.
The descent phase of operation for the Vikram lander has just been initiated with the firing of the 4 liquid engines, which I was mentioning, the 4 throttleable engines. The activity has just started. And right now we are at 35 seconds since the engines have fired. And just to give an update, the Vikram lander, when it was in an orbit of around 30 kilometers, when the descent operation started, it had a velocity of nearly 1,640 meters per second. So almost 6 minutes have elapsed since we started the power descent operation, and we are still in the rough braking phase with the next 4 minutes to go. And if I look at the velocity that has dropped from the time the power descent operation was initiated, nearly 50% of the orbital velocity has been reduced. So we started with 1,680 meters per second. Presently, the Vikram lander is descending towards the lunar surface, and it has a velocity of 760. So we expect in the next 3 minutes, the velocity should come down to something like 146. We are almost maybe in the range of 10 to 20 kilometers. And velocity also is, I think maybe. So a very close match with respect to the pre-flight predictions, which clearly indicates the 4 throttleable steering engines, which has been basically designed for this Vikram lander for the first time, has been performing extremely well. We have almost touched the 630 meters per second. So maybe another 500 meters per second velocity is what we expect to get it reduced. We are maybe 75 kilometers away from the actual landing site. The one thing I would like to just mention here, during the descent phase of operation, as I mentioned, the rough braking phase is the real brute force of velocity reduction. And since we are trying to bring an object from an orbiting around the lunar surface to have a touchdown, there is a need for us to reduce the velocity. It's something like braking. In fact, I think when we reach an altitude of almost the target for this particular rough braking phase is to attain an altitude of 7.4 kilometers, when the velocity should have touched almost 146. So we have finished the rough braking phase now, because the target for that was 7.4 kilometers and the velocity was nearly 140. So the Vikram lander has successfully completed the rough braking phase. And now we have entered the next phase of operation, which is the absolute navigation or attitude control phase. And this particular event is going to last for nearly 38 seconds. And the 4 throttleable engines are continuously on. And we see the velocity is something like 86 meters per second and roughly 4.43 kilometers away from the landing site. So all going well. Just awaiting the announcement for completing yes. The rough braking phase has been successfully completed, and we have entered the next phase of braking operation, which is the fine braking start, which is going to basically commence from 5-kilometer altitude. And this particular operation is going to last for nearly 96 seconds, wherein the Vikram lander will be reaching an altitude of just 400 meters above the landing site for initiating the vertical descent operations. So we are almost 11 minutes 52 seconds after the descent operation has started, just awaiting the announcement for the end of fine braking phase. Maybe in another few seconds, we should hear the announcement that the fine braking phase of operation has been completed. And we expect at the end of this, the vehicle to reach an altitude of almost 400 meters. And the velocity, Vikram lander has a horizontal velocity of nearly 48 meters and vertical velocity of 60 meters per second.
Vikram lander descent was as planned, and normal performance was observed up to an altitude of 2.1 kilometer. Subsequently, the communications from the lander to ground station was lost. The data is being analyzed.
Had it succeeded, India would have become only the fourth nation after the former Soviet Union, the United States and China to have landed a spacecraft on the surface of the Moon. Telemetry showed normal performance parameters continued down to an altitude of about 2.1 kilometers above the lunar surface when communications suddenly cut out. The data showed that at the time, the lander was at least a kilometre off track from the targeted landing site, and the descent trajectory display was showing an apparent lowest altitude of 0.33 kilometres. The Chandrayaan-2 mission was launched back on the 22nd of July from the Satish Dhawan Space Centre on the Bay of Bengal coast. The mission flew aboard the Indian Space Research Organisation's most powerful rocket, the Geosynchronous Satellite Launch Vehicle, or GSLV, Mark III. It consisted of three components. There was the Chandrayaan-2 orbiter, the Vikram lander, and the Pragyan lunar rover. The flight used an orbital raising trajectory, which involved progressively increasing the mission's highly elongated orbital diameter above the Earth till it was large enough to also encompass the Moon. It's a flight path which saves on fuel, but also takes a lot longer, nearly 7 weeks compared to just 3 days for a direct flight. Chandrayaan-2 achieved lunar orbit on August the 20th. It then began tightening its orbit around the Moon into a circular 100-kilometre high orbit. The orbiter then released its Vikram lander on September the 2nd, sending the 1.5-ton lander on a long, slow descent manoeuvre down to the surface. The lander and rover were designed to spend 14 Earth days on the lunar surface, exploring the local environment and conducting scientific observations. With neither the lander nor rover designed to withstand the freezing temperatures of the lunar night, the ground mission was expected to come to an end as lunar night fell. Despite the lander's failure, the Chandrayaan-2 orbiter will continue studying the Moon from orbit for about a year. It's equipped with 8 scientific instruments, including an X-ray spectrometer to measure the chemical composition of the lunar surface, a solar X-ray monitor to study high-energy radiation from the Sun, a dual-frequency synthetic aperture surface mapping radar, instruments to study the Moon's exosphere. An exosphere is a really thin atmosphere, and a radio science experiment designed to study electrons in the lunar ionosphere. The Chandrayaan-2 mission follows India's earlier Chandrayaan-1 lunar orbiter, which launched in 2008 and circled the Moon for about 10 months, discovering water ice on the lunar surface. A third mission, Chandrayaan-3, is slated for launch in 2024. You're listening to SpaceTime. I'm Stuart Gary. The European Space Agency's NearEarth Objects Coordination Centre says there are now some 872 known near-Earth objects, or NEOs, which pose a risk to planet Earth. That's around 4% of the 20,664 known asteroids and 108 known comets whose orbits come close to that of the Earth. And of course, that number keeps increasing. Since the start of this year alone, some 1,377 new near-Earth objects have been discovered. And the concern is very real. Over the past 10 months, 5 NEOs have come closer to Earth's surface than the orbits of communication satellites. The most recent was on the 22nd of June, when a 3-metre-wide asteroid, later designated as 2019 MO, slammed into the Caribbean off the southern coast of Puerto Rico, exploding with the force of a 5-kiloton thermonuclear device. And 2019 MO came as a complete surprise. It wasn't detected until it hit the upper atmosphere, setting off infrasound detectors originally designed to monitor illegal nuclear weapons tests. And it's not alone. Back on March the 1st, a 6-metre-wide asteroid, designated as 2019 EH1, came within 2,300 kilometres of the planet's surface. It had only been detected that day, and it was the 8th asteroid known to have come closer to Earth than the Moon since the start of the year, passing our planet at a blistering 15.61 kilometres per second. Just a month earlier, the 2-metre-wide asteroid 2019 AS5 swooped down to within 8,600 kilometres of the planet's surface on the 8th of January. It was only discovered 9 hours before its close encounter. Then there's 2018 WV1, a 6-metre-wide asteroid that came within 27,000 kilometres of the planet's surface on the 2nd of December last year, just 3 days after it was first detected. It's thought to be a piece of the Moon, ejected into space by the impact of a large asteroid onto the lunar surface millions to billions of years ago. And we haven't seen the last of it. 2018 WV will be back for another close approach in December this year, And more importantly, this asteroid is on the Century Risk List, with the probability of a 1 in 11,000 chance of an impact with Earth sometime between 2085 and 2118. And it doesn't end there. Another 6-metre wide space rock, this one catalogued as 2018 WG, came within 29,000 kilometres of the Earth's surface on November the 16th last year. And scientists didn't detect it until the day after it had passed. And that's the real problem, isn't it? Other than the United States and the European Union, no one seems to be bothering to spend money on a planetary-wide defence system. I'm Stuart Gary. This is SpaceTime. If you'd like to help support SpaceTime and get access to the weekly double-episode commercial-free versions of the show, then come and join our Patreon family. It only costs a few dollars a month, it helps keep the show going, and we offer heaps of rewards. There's bonus audio content and an invitation to join our special Patreon-only Facebook group, where you can come and chat, discuss the show, ask questions, whatever you want, with like-minded listeners and members of the SpaceTime team. Get all the details at patreon.com/spacetime with Stuart Gary. Now that's Patreon, spelled Patreon. Patreon.com/spacetime with Stuart Gary. Details are also in the show notes, or just click on the orange button on our website. And thank you to all our Patreon listeners, because your generosity really does help to support our show. A new study suggests that Saturn's interior flows like honey due to its magnetic field. The findings, reported in the journal Physical Review Fluids, may help solve the mystery of why the ringed world's powerful winds seem to stop 8,500 kilometres below the gas giant's apparent surface. Of course, unlike Earth, Saturn has no solid surface. It's a gas giant consisting mostly of hydrogen and helium moving around fluidically. Strong winds known as jet streams form the appearance of stripes on Saturn's exterior, similar but far less stark than those on Jupiter. One of the study's authors, Dr. Navid Constantinou from the Australian National University, says new data from the demise of NASA's Cassini mission has offered scientists a glimpse into what goes on below Saturn's cloud tops. At the end of its mission, NASA instructed the Cassini spacecraft to undertake a suicidal death plunge into Saturn so as to prevent any possible contamination of any of the ringed world's moons, which could harbour life with Earth microbes. During its final descent, Cassini recorded as much data as it could, transmitting it live back to Earth, until it was finally crushed and ripped apart by Saturn's thick atmosphere and immense gravity. Constantinou says the gravitational measurements reveal that these jet streams continue down to about 8,500 kilometres inside Saturn. That's roughly 15% of the distance towards the planet's core. The findings may help solve the mystery of why Saturn's jet streams stop at a certain depth. See, as pressures and densities increase with depth as you go into Saturn, the atmospheric gases become more and more liquid-like. They're able to conduct electricity and more strongly influenced by the planet's magnetic field. Constantinou says an electrically conducting flowing liquid will bend or distort a magnetic field, and the research shows that this distortion of the magnetic field makes the fluid more viscous, like honey. The author's theoretical models indicate this viscous effect from the magnetic field could be the reason why the jet streams terminate at depths beyond 8,500 kilometres. Constantinou says the mysteries of what goes on inside Saturn and the other gas giants in our solar system are now slowly starting to be unveiled. The findings provide a promising way for interpreting the data of planetary missions and offer a better understanding of the planets in our solar system and beyond.
Very recently, spacecraft Cassini dived into Saturn as part of the end of its mission, and it made detailed measurements of the gravity and the magnetic fields inside Saturn. So from that, scientists were able to understand that the winds that we see at the top of the atmosphere of Saturn go down as deep as 8,000 kilometers, 8,500 kilometers, more or less. This was a new discovery, and it turns out that the depth at which they stop is the depth that the magnetic fields inside start to be strong enough to have an effect on the flow. So the fluid in the outer part of the atmosphere is not really affected by magnetic fields, but as you go deeper inside the planet, because the pressure becomes higher and higher, at some point the pressure is so high that the electrons can pop out of the molecules and move around freely. And electrons that move around freely create currents, and currents are affected by magnetic fields. That's why as you go deep, you expect that effect to start becoming stronger and stronger. And it turns out that in Saturn, the depth at which the the winds stop, it's more or less the depth at which we expect the magnetic fields to start to have a strong effect on the flow. And what's more intriguing is that a year ago, spacecraft Juno went and made some similar type of measurements on Jupiter and found that the winds in Jupiter, they go as deep as 3,000 kilometers in Jupiter. And for Jupiter, that's exactly more or less the depth that people expect that magnetic fields will start to have a strong influence on the flow. So this was suggesting that there somehow must be a common explanation to both, to explaining the depth of the winds in both these gas giants, despite that the numbers are different.
What about that? Jupiter 3,000 Ks, Saturn 8,500. Jupiter's a lot larger than Saturn, far more massive. Is that part of the explanation?
And it has much stronger magnetic field. So because it has much stronger magnetic field, you don't have to go as deep inside for the same effect to kick in. So that is part of the explanation. So up to Juno's and Cassini's discoveries, people notice this coincidence that the depth of the wind is more or less about the same depth at which we expect magnetic fields to start to have a strong effect, but they had no explanation or no physical mechanism to explain why the magnetic fields will stop the winds at this depth. And this is where our research came in. And, we propose a theoretical explanation for how magnetic fields affect the flow and the physical mechanism behind which they start affecting the flow in such a manner so that the winds stop. And when we plug in the numbers, it turns out that we can predict, we make a back-on-the-envelope calculation, and we get pretty close to both the depths that Juno measured for Jupiter and Cassini measured for Saturn. The remarkable thing is this coincidence between Jupiter and Saturn. Although the numbers are different, the explanation, at least from what we believe, seems to be the same. And that's very often the case in physics. You find one common law that, underlies various phenomena. And when you do that, if it turns out that our explanation is correct, which it is, we still need to make more detailed simulations, or we should have more data to confirm that. But if that's the case, then this promotes understanding, because as soon as you have one explanation that you can explain various phenomena, this means that you understand the phenomenon deeply.
Your team must be very happy with all this work that's been done by Cassini. Even in its death throes, it was still able to provide new research, which tells us more about the solar system.
Yeah, and it was a very nice idea of NASA to think, okay, we are done with this spacecraft, but at least we can have a last dive and get a glimpse of what's underneath the Saturn's cloud, which is really hard to do otherwise, because as soon as you do that, you lose your spacecraft or something. So that was very interesting. I remember we were working back on the Jupiter paper back then in September 2017, when we heard that, today is the day that Cassini will dive in, and we were intrigued to wait and hear about the results.
It was a fascinating time.
It's a fascinating time, indeed. We start to learn more on the solar system. We've always been learning, but it seems now that we learn more and to places that we didn't expect that we would have data before.
You're listening to SpaceTime. I'm Stuart Gary. There's been another study suggesting possible fossilized evidence of past microbial life has been discovered inside a Martian meteorite. The new study by Ildikó Zsolai and colleagues from the Hungarian Academy of Sciences suggests a 175 million-year-old Martian meteorite found in 1977 by a Japanese scientific team in Antarctica's Allen Hills icefield contains signatures similar to those produced by iron-oxidizing microbes on Earth. A report in the journal Open Astronomy claims the authors discovered mineralized filament-like organic material embedded in a meteorite catalogued as ALH 77005. Argon gas traces in the meteorite confirmed it originated on Mars. The authors used both optical and infrared spectroscopic microscopy to closely examine a slice of the coarse-grained meteorite, looking for biosignatures. Initial geological examination determined that the 482.5-gram meteorite was composed of about 55% olivine, around 35% pyroxene, 8% maskelnite, and 2% opaques. However, they were also able to detect the presence of spherical and filament-like structures of organic material, that is, biogenic minerals such as ferrihydrite, goethite and hematite, which the authors speculate were built by iron-oxidizing microbes. The authors suggest other signatures for biogenesis supporting the scenario included strong negative delta-13C enrichment of iron, manganese, phosphorus and zinc in the shock melt. You may recall back in 1996 another team of scientists, this time led by David Mackay, reported in the journal Science that they had identified possible evidence of fossilized microbial bacterial signatures in another Martian meteorite, ALH 84001, which had also been found in Antarctica's Allen Hills. The structures found in ALH 84001 were between 20 and 100 nanometers in diameter, similar in size to nanobacteria, but smaller than any cellular life form known at the time of the discovery. In fact, the then US President Bill Clinton held a special press conference at the White House to announce the potential discovery. The scientific community still today continues to debate the merits of the 1996 Martian microbe claims, with many researchers suggesting alternative explanations for the microscopic structures. The debate goes on. You're listening to SpaceTime. I'm Stuart Gary. Iran has now confirmed that a missile did explode on its launch pad at the top-secret Imam Khomeini Space Centre due to a malfunction during testing last month. Commercial Earth observation satellite images of the blast site were beamed around the world within hours of the event, and US President Donald Trump then released higher-resolution reconnaissance satellite images of the damage, showing severe scorching on the northern side of the launch pad, a damaged gantry service tower, destroyed fuel and support vehicles strewn around the launch pad, and, importantly, a badly damaged Shafir missile mobile launcher. Tehran's belated confirmation of the launch pad failure comes as Washington imposes additional sanctions against the Islamic Republic for continuing with its missile program in violation of its agreements under the United Nations Security Council Resolution 2231. That endorsed the 2015 nuclear deal, in which Iran agreed to stop developing medium and long-range ballistic missiles capable of delivering a thermonuclear warhead. The explosion involved what's known as a Simor or Shafir-2 three-stage medium-range ballistic missile. These missiles are based on old Soviet Union SS-1 Scud missile technology. The launch vehicle uses a North Korean Taepodong-2 ballistic missile first stage, which combines 4 Scud missile rocket motors, and a North Korean Nodong-1 ballistic missile, known as the Shahab-3 in Iran, for the upper 2 stages, which are sourced from Egyptian Scud-B and Chinese Scud-C missile technology. The Shahab-3 can deliver a 1,200 kilogram warhead, or 5 MIRV independently targetable multiple reentry vehicle warheads, over a range of 2,500 kilometers. As well as using North Korean missile technology, Tehran also copies its North Korean allies by claiming its illegal ballistic missile tests are all part of a scientific space program. Washington's imposed sanctions on 5 people and 5 entities involved in 2 covert networks supplying Iran's missile program. Sanctions target the Iranian Space Agency, the Space Research Centre, and the Astronautics Research Institute. In May 2018, the United States pulled out of the Iran nuclear deal, citing multiple violations by Tehran, including continued missile tests, continued sponsorship of terrorist organizations such as Hamas, Hezbollah, and Islamic Jihad, and continuing to secretly develop a parallel nuclear weapons program with help from North Korea. Pyongyang has now tested and miniaturized thermonuclear warheads to fit on their missiles, and the International Atomic Energy Agency says the Islamic Republic has explored various fusing, aiming and firing systems to make Iranian missiles more capable of reliably delivering a thermonuclear warhead. However, the oil-rich nation insists its nuclear program is for peaceful power generation only. Still, the United Nations nuclear watchdog says Iran has breached its nuclear deal by continuing to increase its stockpile of enriched uranium and increase its enriched uranium purity, bringing it closer to weapons-grade material. The International Atomic Energy Agency says Tehran has exceeded both its 202.8 kilogram limit on enriched uranium stockpiles, now accumulating more than 241.6 kilograms, and it's increased its fissile purity from the 3.67% it agreed to up to what is now 4.5%. Meanwhile, both the Hamas and Hezbollah terrorist groups, which are funded by Tehran, have increased attacks against Israel, while Iranian Revolutionary Guards have been placing limpet mines on oil tankers in the Persian Gulf and seizing ships transiting the Strait of Hormuz. That's now prompted the United States, Great Britain and Australia to increase their military presence in the region in order to escort tankers through the Gulf, which supplies around a quarter of the world's oil. I'm Stuart Gary. You're listening to Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. The Centers for Disease Control, the CDC, are now getting reports of people dying from severe respiratory illnesses after vaping. The average daily e-cigarette smoker inhales a cocktail of vaporized nicotine, propylene, glycol, and chemical flavoring agents. Emeritus Professor Simon Chapman from the University of Sydney says the full disaster of smoking's health effects didn't become apparent until 40 years after smoking became widespread. Chapman says with vaping only becoming widespread in the past decade, it's still far too early to know the full risks of e-cigarettes, but this may be a canary in the coal mine for what lies ahead. Chapman warns that people vaping are now being treated like human lab rats by the e-cigarette and tobacco industries, which have all now bought into e-cigs and vaping. A new study has concluded there is no single gay gene. The findings, reported in the journal Science, are based on an analysis of the genetic data from over 470,000 people and analysed survey responses about their same-sex sexual behaviour. The researchers could not find any way to meaningfully predict or identify a person's sexual behaviour on the basis of their genes. Scientists did, however, find 5 genetic variants associated with same-sex behaviour and lots of others which they say may also be involved. But at best, they say these variations could only account for between 8 and 25% of variation in same-sex sexual behaviour and could not be used to predict it. The findings suggest that same-sex sexual behaviour is influenced by a complex mix of genetic and environmental influences similar to most other human traits. A study of close to 500,000 people has found an association between drinking sugary or artificially sweetened drinks and early death. A report in the Journal of the American Medical Association found that drinking more artificially sweetened beverages was associated with a higher risk of death from heart and circulatory diseases, while drinking more sugar-sweetened drinks was associated with a higher risk of death from digestive diseases. A report in the journal Nature suggests the radiation from a mystery explosion at a secret Russian naval research station last month was linked to a nuclear reactor breach. The massive blast killed 5 scientists and injured many others. It also unleashed a cloud of gamma radiation some 16 times above normal background levels over the surrounding countryside. Russia's nuclear agency confirmed the blast happened at an offshore platform during tests of a liquid propulsion system involving radioisotopes. Now data from the Russian Weather Bureau has added more to the picture. It's confirmed the detection of strontium-91, barium-139, barium-140 and lanthanum-140 isotopes in both rain and atmospheric readings from the surrounding area. Meanwhile, Norwegian nuclear authorities say they detected an unexplained spike in radioactive iodine-131, while the Moscow Times newspaper is reporting radioactive cesium-137 has been found in muscle tissue from several doctors from the area of the Naval Research Centre. These isotopes would all be created in the core of a nuclear reactor and then released during a reactor explosion or major breach. That all supports the idea that this incident was caused by an exploding nuclear reactor core, possibly from Russia's new Skyfall nuclear cruise missile. Russian President Vladimir Putin unveiled Skyfall last year. It's a nuclear-armed missile powered by an onboard nuclear reactor, giving the weapon almost unlimited range. The missile would use a conventional chemical engine for launch and then switch to nuclear power once in flight by using energy developed by a compact nuclear reactor to heat air entering an intake, causing it to rapidly expand and blast out a rear nozzle as thrust. Of course, another possibility is that this reactor was actually meant to power the long-rumoured Poseidon nuclear-powered mega-torpedo, which is also being developed by Moscow. The size of a medium-sized submarine, Poseidon is believed to be armed with a 2-megaton thermonuclear warhead. It could be launched from a larger submarine under the ice cap and then cruise under its own power to any shoreline target on Earth. A new study of nearly 9,800 firefighters in New York City has found an association between greater exposure to the September 11 terrorist attacks and the long-term risk of cardiovascular disease. A report in the Journal of the American Medical Association looked at the arrival time of subjects at the World Trade Center site, the amount of time they spent there, and their heart health over 16 years. They found that those who were at the site of the attacks on the day, as well as those who continue to return over the next 6 months, had higher risks of cardiovascular disease compared to those who arrived later or who spent less time at the site. Scientists say the results reinforce the importance of monitoring long-term health of survivors of disasters such as the 9/11 attacks. The 9/11 or September 11 terrorist attacks were a series of 4 coordinated terrorist attacks by the Islamic terrorist group Al-Qaeda against the people of the United States on the morning of Tuesday, September the 11th, 2001. The attacks killed 2,996 people and injured more than 6,000 others. Additional victims died of 9/11-related cancer and respiratory diseases in the months and years following the attacks. The attacks involved the hijacking of 4 passenger airliners by Al-Qaeda terrorists. 2 of the planes, American Airlines Flight 11 and United Airlines Flight 175, were crashed into the north and south towers of the World Trade Center in Lower Manhattan. A 3rd plane, American Airlines Flight 77, was crashed into the Pentagon near Washington, D.C. And a 4th aircraft, United Airlines Flight 93, was initially flown towards Washington, D.C., but crashed into a field near Shanksville, Pennsylvania, after its passengers overpowered the hijackers, thwarting their attempts. That flight was believed to be targeting the Capitol building. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favorite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.